So we've not talked about equations just yet, but we can still solve this, right? We can plug and chug because we know a little bit about all of these ordered pairs. And it says which of the following are solutions on this interval. And the only way to check a solution algebraically is just to plug it in, okay? Now, what do you think this means where it says cosine and then there's a squared and then x? Because we've not discussed that either, I don't think. It's kind of in quadratic form, right? This actually means 2 times the cosine of x, and then I'm going to square my answer, okay? So anytime you see cosine squared and then x, it means the whole cosine of x squared, all right? So you evaluate cosine of x, and then you square it, all right? So minus cosine of x minus 1. And what we want to do is we're going to plug in some of these values and see if when I plug it in, I still get 0 when it's over, okay? And that would be the easiest way to kind of approach this until we learn how to solve it in a little bit today. All right. So let's start with 0. If I plug in, what is the cosine at 0 on your unit circle? It is, cosine is x. So that would be the order pair 1, 0. So 2 times 1 squared. Cosine at 0 would be 1, and then minus 1. Let's see if we get 0 when I do that math. 2 minus 2. Yep. So that one's going to be a solution. Right? If I plug it in, I would get that. All right. Let's talk about pi over 3. This is up here. What's my ordered pair going to be at pi over 3? 1/2 and square root of 3 over 2, okay? So cosine is going to be the 1/2, all right? So we're going to plug it in. 2 times 1/2 squared. Cosine at pi over 3 would be minus 1/2 and minus 1. Now, a little more arithmetic on this one, okay? What's 1/2 squared? 1/4. So I have 2 times a fourth minus 1/2 and minus 1, okay? So this is going to give me 1/2 minus 1/2 minus 1. Do I get 0? Yeah, I get negative 1, all right, because the 1/2 would go away. So that one's not a solution. All right, so you see what we're doing? We're plugging it in and we're figuring it out, okay? So just doing a little bit of math, all right? Let's talk about 2 pi over 3. That's going to shift me over into this quadrant. What happens to my cosine over here? It's negative, okay? And let's see if that changes anything. Negative 1/2 squared minus negative 1/2 minus 1, right? It shouldn't change anything with that first term because we squared it, right? So I'd still get 1/4 times 2, which would be 1/2, plus 1/2 minus 1, right? So I'd get 1/2. Did somebody knock? Oh, thanks, baby. I didn't hear it. Okay. And so then 1 minus 1, that's 0. So this one works. Okay. Morning. Did you sign in at the office? Okay. Do you have a receipt? Thank you, dear. Appreciate it.
Yep.
Okay. And then let's try pi. What's my cosine over there at pi? Negative 1. Okay, so 2 times negative 1 squared minus a negative 1 minus 1. 2 plus 1 minus 1. No, that one's not going to work either. Right. So now this is where I think it's interesting because we can kind of follow some patterns, all right? What's our cosine going to be down here at 4 pi over 3? It would be negative 1/2, right? So if it worked when I use negative 1/2 up here, guess what? It works again, all right? So that one's going to work. Right, so we can kind of follow that same pattern. And then 5 pi over 3, that puts me down in the 4th quadrant. What's going to be true about your cosine in that quadrant? It's positive. And did the positive 1/2 work? No. Okay. So a little process of elimination there that we can do to plug things in, just kind of guess and check, all right? We're going to have a much more efficient method for doing that here in a little bit, okay? But for right now, that works, okay? Marshall, I'll put all the stuff on the back table because we're going to do 2 lessons today, okay? All right. So let's talk about what we're going to do today. We're going to talk about key characteristics of functions that involve quotients, all right, of sine and cosine. And so if you remember, let's go back and talk about these. How did we get secant? Oh, it's been a minute. 1 over cosine is reciprocal of cosine. Good. Okay. Yeah, reciprocal. Opposite would mean change, a positive or a negative. Reciprocal means flip. That's a good, I'm glad you said that. Okay. Cosecant would be 1 over sine. Cotangent. We could also write that as 1 over tangent or cosine over sine. Now, we just know those as definitions, but they're also known as reciprocal or quotient identities. Oh, that's what that lesson's about. It's about identities, things that mean the same thing. Okay. So we like to name things in trig, and this is one of the things we do. All right, we call it a reciprocal or quotient identity. So the first thing we have to do is be able to graph these functions, okay? Secant, cosecant, and cotangent. And they look different, all right? They look really different from all the other ones, minus cotangent. Cotangent looks pretty similar to some things we've seen before, okay? But I'm going to show you what I learned to do years ago that's helped me. All right. In fact, a student helped me see it this way because I always tried to graph it the hard way. You know, in college, we didn't have cool things back then. Nobody cared about us in the dark ages. All right. We just had to beat it senseless into ourselves. It's okay. I had to memorize the whole unit circle. It wasn't until I started teaching that I followed a lesson with somebody in a in-service where they did the unit circle. And I was like, oh, this would have been helpful. Right? Because I just tried to memorize everything. Maybe that's part of why I like tricks so much. I don't know. Okay? All right. So let's go through. There's a couple of steps we're going to take, 3, in fact, to graph a reciprocal function. That means secant, cosecant, cotangent. All right? Now, cotangent is the only one that we'll do a little differently just because of the nature of that graph. All right? But mainly this is for secant and cosecant. All right? And so the first thing we do is I like to say we graph the reciprocal function first. That's the graph that we know, all right, which would be cosine or sine. I refer to that as your ghost function, all right? We use it to guide our graph, but it's not really part of it. Okay? So we just use it to guide. A lot of times you'll see it in a textbook, it's dotted. So you can kind of see where the actual graph comes from, which you're welcome to do, but I'll show you what I mean when we get there in just a second, okay? So if I'm asked to graph secant, I'm going to start by graphing cosine. If I'm asked to graph cosecant, I'm going to start by graphing sine, all right? Because those are 2 functions that I can do pretty easily. Cosine being my bird or my crane, cosecant being, sine being my roller coaster, all right? Now, interesting tidbit, all right? Because there's reciprocals, there are opportunities, all right? We have a trig function in the denominator. Are there places where cosine would equal 0? Yeah, and can we divide by 0? No, our paper explodes. So what we do is we get asymptotes, all right? So our asymptotes equal the zeros or the x-intercepts of the ghost. Okay, or of that reciprocal. So wherever my ghost function crosses the x-axis, I'm going to drop an asymptote. All right? Because the function I really intend to do would be undefined there. All right, so now this is where we actually get the piece of the function we want, okay? The graph that we want. You're gonna find that between your asymptotes, your ghost function's either gonna have a maximum or it's gonna have a minimum, all right, because of the nature of what our graphs are, okay? So what we're gonna do is we're gonna flip the ghost. Between the asymptotes. And you're like, Ms. Moore, this is voodoo. All right, it's really not. I'll show you one. Okay, we're going to flip the ghost between the asymptotes, but we keep the max or the min that we see. Okay, so that's going to be our focus point. We will keep that max min point and then flip everything else. All right, so that if my ghost is going down, my actual function will open up. All right, if my ghost opens up, my actual function will open down. All right. They don't ask us to get too detailed into this, so I'm not super concerned about this. All right, but let me show you kind of how that process works. So let's start with the graph of secant, okay? Secant is based on the cosine graph, okay? So let's graph cosine to begin, right? We're going to start on the positive side of the unit circle, so a positive revolution. What does cosine typically look like? That's my bird, okay? So we're going to start up at 1, and we're going to end at 2 pi at 1, okay? And then at pi, it would be down 1. At pi over 2 and 3 pi over 2, it would cross the axis, okay? So if I just do that piece, and I'm going to make it dotted, okay, it would look like that, okay? Now, if we go backwards, all right, it would follow the same pattern, but just in reverse. So I'm going to include it as well. And then dotted line. This is my ghost function. All right, and it would continue. So my ghost is cosine. All right. In order to graph my secant function, I know there's going to be asymptotes. Everywhere that ghost crossed the x-axis, I'm going to drop a vertical asymptote. Okay, so I'm going to drop a vertical asymptote here at pi over 2, at 3 pi over 2. Okay, if we kept going, I'd put one at 5 pi over 2. All right, so you kind of see the pattern. If we go backwards, negative pi over 2 and negative 3 pi over 2. All right, so we've got asymptotes. All right, now we're finally ready to actually graph the function, okay? And we've done a lot of work to get there, okay? So what I'm going to do is look between my asymptotes. So if I go left to right, if I look between my asymptotes, my ghost is opening up, so it has a minimum point. I'm going to keep that minimum point, right? Instead of opening up like my ghost, it's going to open down, and they kind of make U's. They look like little parabolas in between the asymptotes. That is part of a secant graph. Only the purple, right? Everything else is just guidance, okay? When I get to the next section between the asymptotes, right, I keep that max point, all right, part of my graph. Between the asymptotes, the ghost goes down, so my actual picture opens up, all right? We flip the piece that's there, okay? You don't want to hit the asymptotes, but, it's hard to do when you're doing it digitally. Okay, same thing. Next section, keep that minimum point, right? The original ghost opens up, so my picture's going to open down. Okay. Now, if we kept going, what's going to happen? I keep getting u's that go up and u's that go down, right? So they just switch between these u's, and there's this space between 1 and -1 where nothing's really there, okay? The purple is the only thing that's part of this graph, okay? And so how far did we have to go so that I got an up U and a down U when it started to repeat? I went to pi. So my period is still 2 pi. It matches the ghost. All right, so if my ghost is cosine, the period, all right, of cosine is the period of secant. They match, all right, because they're reciprocals. Now, let's talk about domain, all right? Domain refers to the x values that are used, okay? Everything's good except for where our okay. My brother has the flu. He found out Monday he has the flu, and he's been at the hospital. And of course, obviously, he hasn't been able to go back since he found out he had the flu. And now they're having to test Eli for the flu, and if Eli has the flu, he can't leave his room, which would be catastrophic. Because yesterday he got to play all day, and 10-year-olds don't do well sitting in a room all day. I don't know if you knew that, but anyway. Okay. All right. So where are the places where we get those asymptotes? At all the pi over 2's, okay? They happen at all the pi over 2's, which are all those zeros of cosine. So our domain's going to be all real numbers, all right? X can't be, all right? Pick one of the asymptotes, pi over 2 plus or minus. How far is between each asymptote? Close. Pi. It's just pi. Yep. Pi k. Okay. So if I go from pi over 2 to 3 pi over 2, that's half of the circle. Okay. So that's my domain. Range on this one's interesting. Okay. Do we use every y value? No. Pretty close. Which ones do we not use? Yeah, the ones between -1 and 1. Okay. Because between the purple, I don't use any of that stuff. So for our range, we could say this. We go from -infinity to -1, but we use -1. And then we start at 1 and go up. Everything else is good. Okay, so we just don't use anything between -1 and 1. All right. Different looking kind of graph. Okay. Good news is we do the exact same thing with cosecant, but we start with sine. Okay, so it's just a process. I don't look for them to make you graph one by hand, all right, in a free response. In fact, it's not part of what any of the free response questions look like, so that's good news. They're just going to ask you to understand the characteristics of the graph in a multiple choice, all right? So let's look at cosecant, right? Who would be our ghost function for cosecant? Sine. Oh, that got really even eaten. Okay. All right, sine. All right, that's better. All right, so let's start by graphing a sine. All right, what does sine typically look like? It's our roller coaster. So we're going to start at 0, pi over 2. We go up, pi, we're at 0, 3 pi over 2, and so on. And then we could do the same going backwards. So there's our ghost function. Where are asymptotes going to happen this time? Same place, x-intercepts. Now, they're in a different place than the cosine, than the secant, where the cosine zeros are. Okay, but they still happen in the same place. could happen at 0, at pi, at 2 pi, etc. Okay. We do the same process in terms of keeping the max or min and flipping. Right. So we'll do the same process. If I start on the far left and keep going, I get a max and I turn up. I get a min and I turn down for what? I get a max and I turn up. Min and I turn down, so on and so forth. Okay? So it's basically the same picture, just kind of moved a little bit. All right? The one above it had to go a little bit, then I started getting my U's. All right? This one, I get them immediately. Okay. So, big guess based on what I said a few minutes ago. What do you think the period of cosecant is? It's 2 pi. Okay, because the period of sine is 2 pi. Right, so that matches. Right. Let's talk about our domain. The asymptotes are an issue, so it's all real numbers except x can't equal, all right? And there are lots of ways to write this, okay? Where's your first asymptote at if we're looking just at the coordinate plane? Yeah, 0, okay? And then where does the next one happen? At pi. So we can actually say plus or minus pi k. It's all multiples of pi. And if k is 0, that'd be 0. All right, so it just makes it a little bit easier. It's happening at all the pi's, okay? Range. Who's not included on the y values? It's the same as the last one. We don't include 1 and -1. Okay, so negative infinity to -1, 1 to positive infinity. Okay. So that's kind of the trick to those graphs, all right? You have to think about who your ghost is, how would you move it, what does it do to the period, all that kind of stuff. And we can do transformations to these graphs just like we can all the others, okay? We'll actually look at some questions here in a second, multiple choice, where we'll talk about how do I find things like period, asymptotes, things like that, okay? Now, let's talk about cotangent. It's really, really similar to tangent, okay? We are still going to embrace this concept of flipping or a reciprocal, but it's going to look a little different. Where are your asymptotes for tangent? Do you remember? They happen at all of our pi over 2's. Okay, they happen at all of our pi over 2's. Our asymptotes for cotangent, because we flip who's on the top and on the bottom, it's where sine is equal to 0. So they all happen at 0, pi, 2 pi, etc. Okay. So for tangent, I have to go half a period and then throw in an asymptote. I do not have to do that for cotangent. All right, cotangent starts at an asymptote, which is nice. Okay. So cotangent's going to start at an asymptote. So we can throw one in at 0. We can throw one in at pi. We can throw one in at 2 pi, and so on. Okay. So, cotangent starts with an asymptote. Get where you're going, drop an asymptote. Okay. Now, the picture for tangent is that increasing snake in the middle. If I flip it, what's going to happen to my snake? It's just going to decrease, okay? So we're still going to hit 0 in the middle, but we're just going to be a decreasing snake. Okay, and we don't have to get super precise with that, All right, but they would be our decreasing snakes, and we would hit 0 in the middle. So it's still that concept of a reciprocal. We flip that snake, it becomes a decreasing snake versus an increasing snake. Okay. Now, just like the ones before it, what's the period for tangent? Pi. So guess what the period is for cotangent? Pi. Okay. It's pi. Right. When we talk about domain, again, everything works except the asymptotes. Okay. Because I can start there at 0, I'm just going to say plus or minus pi k because it's all the pi's. What about your range this time? It's everything. Okay, that decreasing snake takes care of everybody. So it's all real numbers, just like tangent. Okay, so the only thing that changes between tangent and cotangent is your domain. It's where your asymptote falls. So now that we've seen a picture, let's talk about how we can figure out all the things. All right, because that's where these next questions come in. They're multiple choice, and there's just stuff going on. Okay. Then I'm going to give you a little sneaky peek into equations, and then we'll actually do equations and inequalities here in a second. Stop. Okay. I ordered 3 different dresses because I didn't know which one I wanted to wear to prom, and 2 of them come today. Yay! Okay. And then I'm sending back everything else, but... Okay. All right, rock and roll. All right, multiple choice. So it says, let f of x equal 3 secant of 2x. Which of the following is a vertical asymptote on the graph of f? Okay, here's what we're going to talk about. All right, our ghost for this one would be 3 cosine of 2x. Okay, this is my ghost, and this is where I'm going to start every time, is what is my ghost function? All right. That would be the transformation. So let's talk about how this transformation would change. Okay. What's the 3 going to change in the front? My amplitude. Okay. What's the 2 inside going to change? The period. Okay. The period for cosine is 2 pi. We're going to divide it by 2, and now I get pi. Okay, so that means I got to get a whole crane between 0 and pi, right? So let's just look at that. We're only going to do one side, right? I need to get a whole crane between 0 and pi. That would mean pi over 2 is in the middle, okay? When we graph cosine, we start up, we go down in the middle, and we're back up. Okay. The asymptotes for secant are going to happen at the zeros of my cosine. Okay, which would be halfway between 0 and pi over 2. What value would that be? Pi over 4. Okay, boom. Right? So you can do this as long as you understand how we get to secant, all right, using just the cosine graph, which is nice, okay? So you don't have to worry about transformations of everything else. We can just think about what's the transformation of the ghost, right? Because the zeros of the ghost give me the asymptotes that I'm looking for, okay? All right, let's do another one like that. So this time it tells me that g of x is equal to 4 minus 2 cosecant pi x. That's a lot. All right, I'm going to rewrite that in terms of its ghost. Usually we don't put a number in the front. Where do we typically put it if it's just like being added or subtracted? at the back. So I'm going to rewrite this as -2. Instead of cosecant, I'm going to do sine pi x and then plus 4. All right, so I just want to think about my transformations. Okay. I want to think about my transformations. What's the -2 going to change? The amplitude. And it's also going to do what to my roller coaster? It's going to flip it. So I'm going to go down and then up instead of up and then down. So amplitude, and we're going to flip it. Pi is going to change my period. So 2 pi divided by pi means it's actually what? 2. Okay. And then the plus 4 would tell me to go up 4. Okay, so that's what I'm going to do to my sine graph. All right. So let's mess with that a little bit. Okay. I don't go anywhere left and right, which is good, but I got to go from 0 to 2, which would put 1 in the middle. All right. Weird, but it is what it is. We don't need pi's to have a period. Okay. So sine function starts at 0, middle is 0, end is 0. Okay, we would scoot it up 4, but does that change? No, not really. Okay, it doesn't really change anything. And we would go down and then up. Okay, because if I'm looking for asymptotes, all right, asymptotes are going to happen at the zeros of the function. Of all the numbers that are listed there, which one is a 0? 1. Right? These are thinking, reasoning questions. Right? Where are the zeros of your ghost? It's pretty much what it comes down to. Okay. Let's do about 2 more of these, just thinking about the graphs and their characteristics. So this time it says, let h be 3 cosecant theta divided by 2. Right? So let's think about our ghost for a second. All right. It would be 3 sine of theta divided by 2. All right. So we know it's going to change the amplitude. Okay. My amplitude is going to be 3. What's my period going to be? Okay, remember that's a 1/2 sitting there if it's something over 2 inside of there. So if I take 2 pi and I divide it by 1/2, what's my period? 4 pi. Now, it's asking me about range. Does the period affect my y values that are used? No, all right? So if and you had to guess, all right, we no longer have a range. It went from everything but -1 and 1. Okay, with an amplitude shift, what do you think it's going to be? 3 and -3. Okay, so it's everything but 3 and -3. All right, because what it's done is it's stretched my sine function out so that there's more space, all right, between my u's. All right, does that make sense? So we can do that one without a lot of headache. All right, it asked me about an asymptote again. Okay, it asked me about an asymptote again, so let's play with this one. We know asymptotes come from zeros. We know for cotangent, I hit a 0 once I get where I'm going, which is nice, okay? But I have to know the period to know where those asymptotes are going to fall because that's how much space is between my asymptotes. So is there going to be a period shift for this one or a period change? Yeah. Normally, period is pi, but I need to divide it by 2 pi. So what's my new period? 1/2, okay? Which means if we started the tangent graph 0 and 1 over 2, those would both be asymptotes. The next one would happen at 1, 1.5, 2. Okay, so of my options that are up here, which one's the asymptote? The 1/2. Okay, because it's always that distance of your period. Yeah.
Why did we put 2 pi on top whenever we're dividing a period?
Period for tangent and cotangent is pi, and I always divide it by the constant that's in here. Yeah, that's why it's backwards. It's a little weird. It looks weird. Okay, normal period for tangent. This is the normal period, and this was my transformation. All right. Whew. That's a lot. Okay. Now, we haven't gotten all the way into equations yet, but it's no big deal because we can actually solve these using what we know about the unit circle. All right, which is nice, and we don't have to have any special skills to do that. All right, but I think it's interesting how they phrase this question. So it says, let f of x equal 4 cosecant x plus 3 and g of x equal to 11. Okay, in the xy plane, what are the x coordinates of the points of intersection of these graphs between 0 and 2 pi? All right, so you only have to go around the circle once. And basically what it wants me to do is set f of x equal to g of x. So let's do that. All right, that's basic equation solving 101. So I have 4 cosecant plus 3 is equal to 11. Now, this is unlike any kind of equation I've ever done before. All right. So let's just ignore for a second that there's a cosecant sitting there. Okay. If we were trying to get some variable term by itself, which value would I try to move first? The 3. Okay. That's exactly what I would do. I would try to move the 3 first. So that would give me 4 cosecant of x would equal 8. Okay. What would be the next thing we would do in solving that equation? We'd divide by 4, okay? Just basic equation solving techniques. So you don't really have to know anything about trig equations to get that far, okay? We would try to isolate whatever that thing was that we're looking for. Now, this is where it's different, okay? And this is where we use what we know about the unit circle. We know that cosecant is the reciprocal of sine. So I'm going to rewrite that as sine of x equals, so if I did the reciprocal function, I have to do the reciprocal number. What would be the reciprocal of 2? 1/2. So what this is asking me is between 0 and 2 pi, where is the y coordinate? 1/2. Okay, well, in order for it to be positive, it would have to be in the first and the second quadrant. Which one of our families gives us a y coordinate of 1/2? Pi over 6. Okay, so in the first quadrant, x is pi over 6. What would we call it in the second quadrant? 5 pi over 6. Yep, that's exactly what we do. Okay, using what we know. Okay, on the unit circle one time, because it said 0 to 2 pi, what are those values, those arc lengths that would work? Okay, let's do one more. All right, so this time it says let h equal 3 minus 1/2 secant x and k of x equal 4. Find the points of intersection. So we're just going to set them equal. 3 minus 1/2 secant equals 4. I'm going to give you a second to play with it. Okay. See how we did? We'd move that 3 first. All right, so that would give me negative 1/2 secant is equal to 1. Then I get rid of that negative 1/2, multiply everything by negative 2. So secant equals negative 2. Let's use the reciprocal, okay, because cosine's negative 1/2. Cosine's only negative in the in the second and the third quadrant. Has to be my over 3 family. So that would have been 2 pi over 3 and then 4 pi over 3. Okay, so using our unit circle. All right, last thing. If you notice on your calculator, all right, it does not have secant, cosecant, and cotangent buttons. All right, only ones it's got are sine, cosine, and tangent. All right. Good news is we can still use a calculator. All right, but we have to be a little more creative. All right, so I'm going to show you how we can do that to solve some more complex type equations where we use our calculator to get the intersections, right, where we want to use it. One of our review days we will spend just working strictly on the calculator things that are expected on the AP exam, all right, practicing those skills so we feel confident about those going in. All right, we're doing it in calculator too. So, all right, here we go. Grab your calculator if you haven't already. Next week there will be a day where we have to move or maybe there's multiple days we have to move because we can't be in here because they're going to test in here. I think it's just Monday and Tuesday of next week, but I'll keep you posted and let you know. JJ, that worked last night when I texted you a message? Okay. I didn't know what was a good time frame, so, okay. All right. Is it bad that I'm already anticipating dinner? I'm so excited about what I'm cooking. It's our favorite crock pot recipe. It's so good. It's literally just chicken breast, and you put ranch seasoning and a little bit of, whatever else seasoning you want there, and a little bit of cream cheese, and you just let it cook all day, and then you shred it, and then you put bacon and cheese on it, and you let it just kind of melt. Okay. It would make it really good if I had some toasty sourdough to put it on, but we don't eat that in my house, so we have salad instead. Okay. All right, so let's look at this one. Here's a trick for when you want to solve something with a trig function that you don't have, okay? So I want to show you this. In y1, we're going to put 1 divided by tangent x. And then we're going to turn this equation off. All right, so you might want to write this down first, and then that way you'll have it when you go back, okay? And to turn it off, you just hit enter on the equal sign, okay? So basically what that's doing is it's storing something in my calculator, but I'm not going to see it on a graph, okay? So it stores it where I can't see it. And the reason we choose that is because cotangent is 1 over tangent. Okay. Now, this is the 2 equations we're going to use. We're going to use y2 and we're going to use y3, okay? y2 is where we're going to put the big nasty equation. So we'll do 3 minus 1.7. The beautiful thing about your calculator is it works as a function manipulator, all right? Which means if I put y1, it's like, oh, hey, there's a function there. And in parentheses, I put in what I want it to plug in. It will plug in that value into that other function for me, all right, which is nice. So 0.5x minus 1. So that's how we're going to type it in. Now, you get y1 by doing alpha trace. And then in y3, we're just going to put that number that it was asking me to look for. Okay, where is that nasty equation equal to? All right. Now, you may have to mess with the window, and this is usually what I do, and I say that because notice it says only when x is between 0 and 2 pi. Because the thing about a trig function is it's going to keep going and going and going and going, so you could have you're going to have infinite intersections, okay? So on my window, I'm going to change my x min to 0 and my x max to 2 pi, okay? Because I can type it in just like it's written. All right? So change your window. And then if you can't see enough of the intersection like top or bottom, mess with your y, all right? But I typically don't mess with the y. All right, I just mess with my x. All right, so let's just put that down, and then we're going to physically do that on the calculator and see if we can all get the same answer. Okay. I'm gonna pull mine up here in just a second. I was just letting everybody get that written down. I wanted it. Okay. All right, let me pull my calculator up. Okay. So y equal, let me clear out what I got there. So 1 over tangent x, and then I'm gonna hit enter on my equal sign and turn it off. Okay. And then I'm gonna have 3 minus 1.7 alpha trace y1 parenthesis 0.5x minus 1 and then 2. Okay. So that's what it should look like on in your y equals. Okay. Then I'm going to go to window and change my x min to 0, my x max to 2 pi. Hit enter. Okay. And then we're going to graph and pray for the best. Okay. All right. So we're looking for where there's an intersection. Okay. Mine is happening over around 4, it looks like. Okay. How do we do intersection on the calculator? Second trace. Number 5 is intersect. Now mine works a little different. Yours will say, does it say first curve, second curve, guess? Okay. I have to move mine to the left and right. So first curve, you can just say yes. Second curve, yes. Do you want me to guess? Yes. Okay. And so your intersection happened at about 4.078 for x. Okay. 4.078. Yeah, this app works a little bit differently for things like that. I don't like that part about it. Okay, but it's first curve, second curve, guess. Okay. So if you don't remember about finding an intersection, okay, second trace 5, right? And then you have to enter 3 times. Okay. So our x value that we wanted was 4.078, always taking those 3 decimal places. Okay? All right, secant, cosecant, cotangent. Graphing, all right? We're going to do more of equation solving here in a second, so I think you'll feel more confident about that once we get into it, all right? And then using a calculator to do so, all right? Your practice, let me tell you which ones to do out of 311. Okay. Okay, on worksheet A for 311, 1 through 5. Okay, 1, 2, 3, 4, 5. And then on worksheet B, 1, 3, 4, 6, 8, 9, and 10. Okay. Now, your wrap up for this, I think, is on yesterday's post. I did not go in and change everything because I was tired. Okay, so your wrap up, so let's do that real quick, should be on your post for what's today? 22. Okay, so do that. We're going to take a little TV time out, all right, till about 10 o'clock, okay, or a little after. Okay, if you need a snack, get a snack. I'm going to open the door. If we need to tinkle, let's tinkle. All right. Okay, let's don't get real loud, but we can chillax for a little bit, and then we'll come back and do that other lesson.